Okay, we are going into topic 2 in our 8th grade math. This is going to cover topic 2, the first part of lesson 1. Okay, so I just want to remind you about a couple of things. We have learned and been talking a lot about our XY axis on a coordinate plane. We have learned about proportional relationships. Proportional relationships pass through the origin, and they are modeled by the equation y equals kx, which we now change to y equals mx. M is the variable that represents the slope. So, we also learned about the equation of a line that is non-proportional, so it does not pass through the origin. And that looks like y equals mx plus b, where b is our y-intercept. We can also refer to that as our starting point. And m is the slope, also known as the rate of change, or how our line changes over time. So our x-axis is going to be what we call the independent variable. Our y-axis is the dependent variable. Let me see if there was anything else I wanted to talk about. Okay, one easy way to remember the slope is to say rise over run. We can also call it the change in y values over the change in x values. So that's what we're going to learn about this whole lesson. We're going to be calculating the slope and getting really good at practicing that. So this is on page 305, by the way. I'm sorry for not saying that at the beginning. So now we're going to move on to page 306. So if you missed class, we're going to do like a group activity where we look at this in different groups. So if you missed that opportunity, then you're just going to have to watch this video and we'll go over it together right now. So the scenario says you work at a local custom t-shirt shop over the summer. One of your responsibilities is to calculate the total cost of customers' orders. The shop charges $8 per shirt plus a one-time charge of $15 to set up a t-shirt design. That is the key information here. So describe the problem situation and your responsibility in your own words. So we could say something like, we work at a shop that charges $8 per shirt. And then for every new t-shirt design, there is a one-time fee of $15. Is the relationship between the number of shirts ordered proportional or non-proportional and the total cost? Well, the key thing being that every new t-shirt design has a one-time charge of $15. That is going to tell us that we have a y-intercept. we have a starting point that's not 0, 0. So since we have a starting point that is not 0, 0, we know we are going to have a non-proportional relationship. Because if we did not have that setup fee, we could start at $8 per shirt. So we have 0 shirts, $0. 1 shirt, $8. 2 shirts, $16. 3 shirts, $24. And so on. But that's not what we have. We have a shirt is $8 each, but we're going to start, I'm going to say that's 5, 10, and 15. We're going to start with a one-time fee of $15. So we're going to start at 0.15 because we're always going to have to pay that one-time fee of $15. And then we can go up by $8 per shirt from there. Okay, so that's how we know. We're going to have $8 per shirt, but we're going to have to pay that $15 to start out with. Okay, so let's move on. Let me make a copy of this page. Okay, so we're going to analyze various customer orders with that local shop. So what is the total cost for an order of 3 shirts? So we know it's $8 per shirt plus a $15 fee every time we have a new design. So 8 times 3 is 24, and 24 plus 15 is 39. So 3 shirts would be $39. So 10 times 8 is $80 plus the $15 fee. So 10 shirts would be $95. 100 shirts at $8 a shirt is going to be $800 plus the $15 fee. So that would be $815. How did we calculate each total cost? $8 per shirt plus $15 initial fee. Initial means first, beginning or first. Okay, so if the order doubles, does the total cost double? No, it doesn't. Because look, let's go with the 10. 10 times 8 plus 15 is equal to 95. So if we had 20 times 8, that would be 160 plus 15 is 175. That's not double 95. So we just have to go $8 per shirt plus the $15 fee. The order doesn't double, or we could say this. We've got $95 for 10 shirts plus the setup fee. If we add 10 more shirts, that would be $80. And so that's going to be $175. We don't have to add that setup fee again because we've already paid it. And it's just a one-time setup fee. So let's keep going and see what comes next. How many shirts can a customer buy if they have $50 to spend, $60 to spend, and $220 to spend? So now we're going to go in the opposite direction. We're going to start with the money and work backwards to see how many shirts we can make or buy with that amount of money. So let me get a different color here. So now I'm going to say I have $50 to spend. How many shirts can I buy? Does this look familiar? Y equals mx plus b. So we're going to start always with $15. We're going to pay $8 every time. So we need to know how much we can buy for $50. So let's set up an equation and solve the equation. So I want to see how many shirts I can buy for $50. That's my X, number of shirts. So I need to know how many shirts I can buy. So I need to get my X by itself. So I'm going to subtract 15 from both sides. A positive 15 and a negative 15 make 0. So that cancels out. So then I do my subtraction here. And I have 8x is equal to 35. This is my number of shirts. So I'm going to divide both sides by 8 so I can get that x by itself. So that goes away. And then I have 35 divided by 8. 4 times 8 is 32 with 3 left over. So can I buy 4.3 shirts? No, I can't. So with $50, I'm only going to be able to buy a total of 4 shirts because I can't buy a third of a shirt. So I can buy 4 shirts for $50. Okay? Just want to make sure you can think about that and that makes sense to you. And then we're going to do this one with 60 together. And then I would like for you to pause the video and do the 220 by yourself. And then you can come back and see if you solved it correctly. So I'm going to go ahead and erase all that. So if you need to pause because I'm going to erase this now. Okay. So if I have $60 to spend, $8 per shirt plus the $15 fee. So I'm going to take my equation and subtract 15 from both sides. And that comes out to 0 right there. So that goes away. So now I have 45 is equal to 8x. I'm going to divide both sides by 8. That becomes an invisible 1. We don't have to show it. So 45 divided by 8 is 5 times 8 is 40 with 5 left over. So we can't have 5.5 shirts. So we're going to have 5 shirts. So this one was 3 shirts. This one is 5 shirts. So I'm about to erase. And this one gives me 5 shirts. So I want you to pause. I want you to work out the 220 by yourself, just like we did with this one and this one. Please pause it. Try to do it by yourself. And then come back and see if you can get the same answer that I got. Okay, so now I'm going to set up 220 is equal to 8x plus 15. I will take 15 from both sides. And I'll get 205 is equal to 8x. So now I'll divide both sides by 8. This gives me my invisible 1. And I'll take 205 divided by 8. 2 times 8 is 16 with 45 left over. So I can put that in 6 times. No, I'm sorry. I just got to thinking wrong. 5 times, and I can buy 25 shirts with $220. Okay? Explain how you calculated the number of shirts that the customer can buy. We set up an equation and solved for X. Okay? Let's see what we have on the next page. Okay, let's keep going. Let me make a copy of this page. Identify the variable quantities and constant quantities in this problem situation. Include each quantities unit. So what do we think the independent variable is? What do we think the dependent variable is? Well, I think the independent variable is the number of shirts. And the dependent variable is going to be the total cost. Because you can always ask yourself, what depends on something else? So the total cost depends on the number of shirts we need to buy. Make sense? Oh, this says the variable quantities and constant quantities. So I kind of maybe mixed this up because now it says independent and dependent variables. But let's see. The constant quantities is we're always going to have a $15 one-time setup fee when we design a new shirt. And the variable quantity is the cost per shirt is $8. The variable is the number of shirts we need to buy. Or let's just say the number of shirts that are ordered. So that would be our variable. Our coefficient of that variable is $8. Remember, a coefficient is a number that comes in front of a variable like this. And in this case, our coefficient is our slope of $8 per shirt. Okay, so complete the table of values for the local shop. This doesn't really give us the number to go by, so we can just make up our own. Let me see what I did. We can just do whatever number we want. So let's say we order 2 shirts, 5 shirts, 10 shirts, 20 shirts, 50, 100, and 200. So now let's figure out the total cost for each of those. So we're going to multiply each one by $8, and then we're going to add the $15 one-time setup fee. So 16 plus 15 is 31. 5 times 8 is 40, plus 15 is 55. 10 times 8 is 80, plus 15 is 95. 20 times 8 is 160, plus 15 is 175. 50 times 8 is 400, plus 15, and that's 415. 100 times 8 is 800, plus 15, 815. And 200 times 8 is 1,600 plus 15, which would be 1,615. So that's how we can get the total cost no matter what number of shirts get ordered. That's how we would figure it out every single time. Let's just take a look right here, because I kind of flew right past this when we started this page. Variable quantities are quantities that change. Constant quantities are quantities that don't change. So every single time we're going to pay that one-time $15 fee when we design a new shirt. And then every single time, the number of shirts that are ordered might vary or change. So that's the variable quantity. Okay, so we're almost done with this activity. The video will stop when we get to activity 2. This is activity 1. So let me make a copy of this page and let's go over it. Create a graph of the data from your table on the grid. First, choose your bounds and intervals by completing the table. Remember to label your graph clearly and provide a title. So now we're going to use this coordinate plane right here to graph that. Okay, so what I did, I didn't come up with that. So we're going to have the number of shirts. Let's do our X and Y axes first. So this is going to be our X and this is going to be our Y. So our number of shirts is going to be down here. And on the side is going to be the total cost in dollars. So let's look at this. We went from 2 to 200 number of shirts ordered. And then we went at a total cost of $30, $31, all the way up to 1,615. So I think we need to go by 100s on our y-axis. Let's see. 0, 100, 200, 300, 1,200, 1,300, 1,400, 1,500. Okay. Then on our shirts, let's count by 5s. Let's count by 20s. Let's count by 20s on our number of shirts. So here's 0, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. I'm going to erase that because I think we can count by 10s. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. Okay, that's not enough spaces, but that'll work. So I'm going to say my lower bound for my number of shirts is 0, and my upper bound is 150. My lower bound for my total cost is 0, and my upper bound for my total cost is 1,500. These are going at an interval of 10, and these are going at an interval of 100. So now let's graph. So if we buy 2 shirts, we're going to pay $31. So I'm going to put that right about right there. If we buy 5 shirts, we're going to spend $55. So right next to it. 10 shirts is $95. So here I am on the 10. I'm going to go right up there. So see, these are real close together. I'm going to erase that and do it again. So I've got right here, right here, and right here. 20 is at 175. So I'm going to put that right there. 50 is at 415. So right above the 400. 100 is at 815. Right there. And 200 is at 1615. So that was going to be somewhere around here and somewhere up here. So now I'm going to graph that all together, or connect the dots. And it will look like this, kind of. Okay, define the variables and write an algebraic equation for this situation. So we've been doing that this whole time. The slope, the variable for slope is m. And we know it's $8 because it's $8 per shirt. The y-intercept, that's what is our variable b. And we know it's $15 because it's a $15 one-time fee. So then our y and our x coordinates, they are just going to be our variables that are there in the equation. So our equation is going to look like this. Y equals 8x plus 15. We have a positive slope. We have a 0.15 as a starting point because that's how much it costs to set up the whole thing when you're going to order shirts. Starting point. Okay, so that is working through a whole scenario of how you can find what your equation of a line is when you have a starting point that's not 0. We have a non-proportional graph, and I apologize, my line doesn't look very good here. It should probably look something like this. But those numbers, those little dots are really close together, so it's kind of hard to see. But that's our activity 1 for lesson 1 on topic 2. So next video will be activity 2. See you then.